Welcome back to the Deep Dive, where we take complex source material and turn it into, well, actionable and memorable insight for you. Today, we are going deep on a fascinating new frontier. It's all about how organizational intelligence is moving past those, stagnant dashboards and becoming truly autonomous.
Self-correcting, and I think this is the most important part, fast.
Okay, so let's unpack this. Our sources detail a closed-loop structure,
Right.
and they're calling it the EON Data Flywheel.
Right.
This isn't just about collecting data better. It's about a system where the organization learns, adapts, and actually fixes itself based purely on what users are doing in real time.
Think of it less like a passive report and more like a constantly running auto-optimized machine.
And it's built to tackle a huge systemic problem.
A huge one. Our sources call it the action gap. And you see, organizations, they have perfected the art of data collection. I mean, we have telemetry streams, rich behavior maps.
Endless logs.
Endless user logs, but turning that mountain of observation into, scalable, profitable product decisions.
That's the gap.
That is the chasm where most institutional intelligence just dies.
So the organization's brain is full of information, but its hands are tied when it comes to actually doing anything with it. It's analysis paralysis on a massive scale.
Precisely. The data is all there, but the system relies on slow, subjective human interpretation to move forward.
And that's our mission for this deep dive. We want to show you exactly how this new system uses what they call AI-powered learning loops to bypass that gap.
It's about transforming those raw behavioral signals into measurable, automated improvements. We are really looking at the mechanism that's designed to end the analytics deadlock for good.
To really get why this approach is so radical, we have to understand the crisis it solves. And there are some real numbers here that show just how much that action gap costs.
Yeah, the numbers are pretty staggering.
For instance, the source material says that a whopping 80% of institutions really struggle just to prioritize fixes effectively.
80%. And that leads directly to stagnant product roadmaps, where teams are just arguing about what to build next instead of actually building it.
And there's a hidden cost to that indecision, isn't there?
Oh, it's enormous. The analysis shows that up to 40% of development hours are just lost, wasted trying to interpret analytics.
40%. So that's nearly half of your most highly paid, highly skilled technical people.
Spending their time in meetings, in subjective debate, trying to manually connect the dots between a data point and a solution.
Because the data informs, but it doesn't clarify or, dictate what to do.
Exactly. And that flawed process hits the bottom line hard and fast. We see figures showing rapid exits, that's users just abandoning a feature because it's poorly optimized, are often 15 to 20% higher.
Wow.
It creates this massive inefficiency. But here's the most damning metric, the one that really defines the action gap.
Okay.
Only 1 in 5 insights generated by traditional analytics ever drives a measurable improvement.
Only 1 in 5. So 4 out of 5 times, the effort to find a problem and figure out a fix is just wasted.
It's lost in the noise and subjective judgment, or it just, never gets executed. That 1 in 5 number is so critical.
It really is.
Yeah.
It suggests the problem isn't bad data, it's a failure of the process itself. The dashboards are great at showing you symptoms, but they're terrible at writing the prescription.
That's a perfect way to put it. The core challenge is that dashboards show you history, but actionable improvement gets bogged down in subjectivity. This tool addresses that fundamental need for systems that don't just alert you.
Right.
They actively propose, validate, and adapt autonomously without needing a committee to sign off at every single stage.
So here's where it gets really interesting for me, and honestly, where I have some healthy skepticism. You're talking about systems that propose and adapt on their own. That sounds less like a software tool and more like an organization's autonomous immune system. How does the EON Data Flywheel physically do this? What's the core mechanism here?
That immune system analogy is spot on, actually. The flywheel is so transformative because it replaces those subjective interfaces with continuous automated improvement cycles.
So it shifts the whole focus from reacting to just evolving.
Exactly. And the engine of that evolution is what the sources call the learning loop.
The learning loop. Okay.
Yes, that's the core mechanism. It's an automated, closed cycle where observation leads directly to an adaptive correction.
And these loops are running all the time.
Continuously. They are not waiting for a quarterly report or some manually triggered analysis. They are watching every single user interaction, diagnosing friction, and proposing fixes in real time.
It sounds like the positive benefit here is just this perpetual state of optimization.
Precisely. By automating the diagnostic part, the system immediately finds the root issues, it prioritizes fixes based on real user impact, and then it generates actionable recommendations with a precision that, frankly, human analysts just can't match at scale.
So functionally, the flywheel is converting the chaos of raw user behavior into a concrete corrective action.
Yes, and it ensures that the vast majority of insights, not just that 1 out of 5, are automatically funneled toward a validated fix. That right there closes the loop on all that wasted data.
But going from raw clicks to a reliable fix, that seems like it requires incredibly sophisticated input. I mean, a human can watch a user struggle and understand their intent, but a machine just sees clicks and session time.
Right.
How does the system understand why a user is clicking, or maybe more accurately, why they're flailing?
And that is the absolute core advantage detailed in the sources. It's something they call the Behavioral Signal Taxonomy.
Right.
It's all about differentiating valuable, intentional signals from just random noise. The system doesn't just log activity, it categorizes user intent into 2 big buckets: confusion and satisfaction.
Let's break those down, especially confusion. What is the AI actually looking for that signals frustration?
For confusion signals, it's looking for these complex, observable patterns. The sources use a great term for it: flailing behavior.
I love that term. It's so visual.
It really is. Imagine watching someone just repeatedly, rapidly clicking on stuff that isn't functional, or they hit an error message and just bounce. They're gone.
Or clicking back and forth between the help page and the feature itself.
Exactly. The AI sees that as a clear signal of failure, even if no technical error code was ever generated.
And that's a huge distinction. Identifying failure without an error code, it means the system is diagnosing design flaws, not just bugs.
Precisely. And then on the flip side, you have satisfaction signals.
Right.
This is where it monitors patterns that confirm a good outcome. Things like voluntary returns to a feature or extended focused engagement where a user just sails through a workflow without any hesitation.
So what's really fascinating about that is that the focus is on these patterns over time.
And across user segments, yes, it's about finding systemic, chronic issues. This gets teams past just, anecdotal complaints or one-off glitches.
And it gives them evidence-backed urgency for a fix. They can be confident that the solution will actually improve the experience for everyone.
Right. That deep, nuanced understanding of user intent is what fuels the prioritization engine. If you can define failure that clearly, you can prioritize with the same level of precision.
Which brings us to the next step. So we've identified the systemic confusion. How does the system filter all that data into a manageable, actionable queue without just adding more noise?
This is where the issue detection and severity modeling comes in. The system automatically categorizes everything and prioritizes the fixes.
And the algorithms are picky.
Ruthlessly efficient. They're designed to emphasize the high-impact failures, the causes of that flailing and abandonment, while actively filtering out the low-impact cosmetic stuff.
That filtering is so important. If you're trying to save that 40% of dev time, getting rid of the noise is the first step. It lets them focus on what really matters.
Absolutely. The system tracks how persistent an issue is across thousands, even millions of sessions, so the urgency is always tied to real institutional impact. But the real game changer is the output.
Okay.
It doesn't just give you a ranked list, it delivers execution-ready instructions.
Wait, I have to challenge that a bit. When you say execution ready, is that just a really detailed report, or is it closer to, like, a development brief?
It's the latter. The sources detail this automated recommendation generation process. The recommendations are structured as concise problem statements.
So they say, here's the bad thing we saw.
Exactly. Here's the negative behavior, here's the exact feature causing the trouble, and here is the desired behavioral outcome you're aiming for with the fix. It removes all the ambiguity.
So, using an example, if it sees a confusing checkout process, it'll generate a recommendation for a specific type of solution.
Yes, and the output is highly focused on reducing friction. So the recommendations usually fall into a few key categories: UX simplification, workflow reduction, maybe guidance augmentation.
Like adding a tutorial at a key point.
Right, or performance fixes for speed issues. The goal is always to reduce the cognitive load on the user.
But the system claims to be autonomous, which means it has to learn and validate its own suggestions. How can it possibly validate a fix against behavioral outcomes before a developer even touches it?
And that is the ultimate closing of the loop. It's captured in what the sources call code-level and product-level guidance. The system uses things like sophisticated A/B testing or even simulation environments to test microchanges against predicted outcomes. It's giving developers instructions that have already been behaviorally validated by the AI itself.
So when the human team goes to execute the fix, they already know it's going to work.
They know the systemic confusion will be resolved because the system has already confirmed the positive behavioral outcome.
That is profound. The system isn't just finding flaws. It's essentially writing the brief for the developer and proving it will work before anyone writes a single line of final code.
It completely transforms the human role from that endless debate over what to fix to simply executing validated improvements.
This whole system really paints a clear picture of massive, immediate positive impact. Platforms don't have to wait for a painful quarterly review. They get these immediate improvement cycles.
And critically, the teams themselves gain so much autonomy. They aren't bogged down in that subjective data interpretation anymore. Their energy shifts from that slow, expensive analysis paralysis into dynamic, precise development.
When you put it all together, from the behavioral signal taxonomy all the way to that code-level guidance that validates the fixes.
You realize this new era of autonomous improvement really does mark the end of the analytics deadlock. Never before have behavioral insights been translated into product evolution with this kind of precision and efficiency.
It just resets the bar for what institutional intelligence can be.
It really does.
So what does this all mean for the organizations that are adopting this? It means their product teams can finally match the speed of their users' real needs. They can evolve dynamically and shed that crippling 80% waste rate we started with.
The organization itself becomes a self-optimizing engine. It's fueled directly by the signals of user success.
Which leaves us with a final provocative thought for you to carry forward. If a system can autonomously diagnose its own flaws, prioritize them, and even validate its own fixes based purely on observable user confusion and satisfaction, what does that mean for the future role of human decision makers in product design?
And where does that shift their focus? Is the critical human element now moving away from that tedious diagnosis and debate and entirely into high-level strategic orchestration and, setting the overall mission?
Something to mull over as you build your own intelligence systems. Thanks for diving deep with us.